Hello everyone. So this is the last slide I have presented now. So we now proceed with the next slide. So we have chapter 4 now. So we're done with chapter 3 and I will discuss now about chapter 4 concerning sampling distributions. Okay, description of this chapter. This chapter deals with a statistic having a normal distribution, t-distribution, chi-square distribution, or an F distribution. So I have already introduced to you normal distribution in the previous chapter. No? So I will now introduce other distributions, no? Such as the t-distribution, chi-square distribution, and the F distribution. So these are all probability distributions. Okay, now, as you notice, there is a word statistic here. So later I will discuss what statistic is all about. But for your information, it has a relation with random variables. No? It has a relation with random variable. Okay. So objectives of this chapter. No? So after completing the chapter, you are expected to solve a probability of concern for a statistic having a normal distribution. Now, solve the probability of concern for a statistic having a t-distribution, and then solve a probability of concern for a statistic having a chi-squared distribution. Lastly, to solve a probability of concern for a statistic having an F distribution. Okay, here's the introduction to sampling distributions. So let us define first what a population means. So as stated, it consists of the totality of observations with which we are concerned. No? So totality of observations with which we are concerned. So actually, sampling distributions, okay, is the introduction to our to conducting a research study. No? So in your research study, there is a chapter called methods. So in that case, you need to understand what the terminologies used. No? So in research, and we have here population. Okay. So population, it consists of the totality of observations with which we are concerned. Now, let's say a research study is about sensitivity. So sensitivity of electricity meters, okay, at 40 degrees Celsius ambient temperature. So when electricity meters are subjected to a temperature of 40 degrees Celsius, how would we describe their sensitivity? So as you notice, sensitivity of electricity meters, I'm referring here um, the energy measurement of the electricity meters. So will it be affected, the energy measurement of an electricity meter, when subjected to a temperature of 40 degrees Celsius? Okay, so that is our uh, That is our research all about. Now we will discover whether the energy measurement of that meter, okay, will be affected by an ambient temperature of 40 degrees Celsius. Okay, so then you will gather data, no? And in gathering data, there is what we call as population. So in here, your population is population of electricity meters in an electric distribution utility. No? Now, this is your research study, and you have to identify your population because you will gather data here. In your research, you have to identify the population. And as you notice, this concerns about electricity meters from a specific electric utility. Okay, from a specific electric distribution utility. Okay, you will gather meters, no, so that you can have data. Okay, so in that case, okay, so we have here sample, no, so it is a subset of population, no, so sample, it is a subset of a population. Okay, as I have told you a while ago, so our the population is electricity meters in a specific electric distribution utility, right? And considering the sample, let's say, so we have electric meters, okay? You will gather meters from a utility, okay? And then you will only select certain number of electric meters, right? You will not select everything, every electric meter in that utility, no? So what you will do is you just select a certain number of meters in that utility, no? That will serve as your sample. Let's say you have selected um, six, no? Let's say 6 meters gathered, no, from that utility. Okay, so this is your sample size now. You have 6 meters. Okay, that's your sample size. So 6 meters gathered. Okay, now that is a subset of the population, no? Because your population is electricity meters in a distribution utility, and you will gather data from those meters of that utility, and you will only select 6 meters. Okay, so these 6 meters came from the population of that utility, no? So we call it now subset of the population. So we have to sample. Okay, now there is, take note of this, no? Any sampling procedure that produces inferences that consistently overestimate or consistently underestimate some characteristic of a population is said to be biased, no? So your sampling procedure might be like this: selection of observations or elements from a population, such that every element is given an equal chance to be selected to be part of the sample, right? So, or the other way around, it could also be selection of observations or elements from a population such that every element is not given, no, is not given an equal chance to be selected to be part of the sample, no. So if that's the case, okay, the sampling procedure is said to be biased, no. So take note that any sampling procedure that produces inferences, when we talk about inferences, we're referring to a conclusion, okay? We're referring to a conclusion that produces inferences that consistently overestimate or consistently underestimate some characteristic of a population is said to be biased, no? So I'll give you an example to this. So for example, suppose we have electric meters. Okay, they are classified into two. We have the electromechanical type. Okay, then we have the electronic type. So you have these two meters, right? These two types of meters, I mean. So suppose in an electric utility we have 6,000 meters. Okay, so of which from these 6,000 meters we have 3,000 meters are electromechanical. No? So electromechanical type, let's say type that is type A, electronic type that is type B. Okay. Alright, suppose we have here electric meters and of which we have two types, electromechanical type and electronic type. Let's say for the electromechanical type, let's say that is meter A, no? Meter type A. For electronic type, we have the meter type B, no? So if we have, for example, 3,000 meters type A, another 3,000 meters, okay, type B, and we are to gather meters. In gathering meters, suppose you decided to take 0.1, 0.2%, no? Suppose you decided to take 0.2% of those 3,000 meters, no? What is 0.2% of 3,000? So that's about 6 meters, right? That is type A. And for type B meter, you decided to take 0.1% of those 3,000 meters and you will get 3 meters. Okay, type B. Now as you notice, there are more electromechanical type meters you have selected than electronic type meters for type B. So since there is imbalance, no? So there's a big possibility that the characteristic of the population will be overestimated or underestimated because you selected more electromechanical types, no, than electronic types. Okay, so the characteristic of a population may be overestimated or underestimated depending on the data, no? That this 6 meters and 3 meters will provide, no? So in that case, since in my example, in my research uh, study, my research study concerns about what? Concerns about sensitivity, right? Sensitivity of electricity meters. And sensitivity here is actually the characteristic. This is the characteristic of the population, the sensitivity of the electric meters. Okay? So this characteristic, no? So we call it parameter. This characteristic we call parameter. If our concern is about characteristic of the population. Okay? So the characteristic of the population now may be overestimated or underestimated. So because there is imbalance, right? When it comes to the number of meters you selected, no? For the two types, no? So you chose 6 meters for electromechanical type, 3 meters for electronic type, and and it is said to be biased. This is now said to be biased because the characteristic of the population, okay, will be overestimated or underestimated. No? Okay. Now, if, for example, if same percentage, 0.1%, no? This 0.1%. This is now said to be unbiased. Okay? So this is now said to be unbiased. Alright, so we now proceed. So to eliminate any possibility, okay, to eliminate any possibility of bias in the sampling procedure, it is desirable to choose a random sample in the sense that the observations are made at random. In this example, we have 3 meters and 3 meters selected, no? And it is said to be unbiased, no? Now, this 3 meters for meter type A, no? So, from these 3,000, no, you will select 3, okay? So, every electromechanical type meter should be given a chance to be selected, okay? They should be given a chance to be selected, no? Hindi pwede na yun lang gusto ko, no? Doon sa 3,000. Kasi puro bago na lang ang pipiliin ko. So, dapat pati yung luma, i-consider natin. To eliminate to eliminate bias, no? In the sampling procedure. So, yun ay random sampling, no? Okay? Yun ay random sampling. So, pipili ka ng mga metro sa meter type A at doon ay dapat uh, whether you like the meter or not, dapat kung napili mo yon, kung nabunot mo yon, kung lottery method man yan, kung nabunot mo yon, yun dapat, no? To eliminate any possibility of bias in the sampling procedure, it is desirable to choose a random sample. Okay? So, in the sense that the observations are made at random. Okay? Pag sinabi natin random, okay, whether you like it or not, kung yun ang nabunot mo, dapat yun. Okay? Kung yun yung metro na nabunot mo, dapat yun ang iselect mo. Okay? So, ganun din sa meter type B. No? Ganun din ang gagawin mo. Okay? Baka puro bago yung piliin mo. So, dapat maging fair. Okay? Para yung characteristic ng population ay hindi ma-overestimate or ma-underestimate. Okay? So, yun ang goal ng ating research. No? Hindi naman natin kailangan lahatin. Yung lahat ng 6,000 meters ay i-test natin. So, kailangan lang natin pumili ng mangilan-ngilan. No? At yung napili natin na yon ay magre-represent sa kabuuan. No? So, yun ang sensitivity. Yung ating concern ay sensitivity of electricity meters at an ambient temperature of 40 degrees Celsius. Okay? So, we now proceed. No? So, we have here a statistic. So, when we talk about the statistic, it is any function of the random variables constituting a random sample. No? Okay. So, in my example about electricity meters, no? So, we have here the formula. Kasi ang ating concern ay sensitivity, right? So, sensitivity of electricity meters. Ngayon, ang sensitivity ay naka-express sa energy error. Percent energy error na kada kilowatt hour meter, or should I say kada electricity meter. Okay? Percent energy error. So, yung formula niyan ay ito. Percent energy error, that is energy at 40 degrees Celsius, no? So the energy, no, measured by a certain meter, okay, at 40 degrees Celsius. Let's say the period is 1 hour. For a period of 1 hour, the energy measurement of a certain type of meter, okay, or any meter from those 6 meters in my example. So minus the energy measurement at 28 degrees Celsius. That will serve as my reference because at 28 degrees Celsius, the temperature is neither hot nor cold. No? So 40, mainit na yan. 28, parang ito yung neutral. No? So over 28 over the energy at 28 degrees Celsius. No? Energy measurement of the meter at 28 degrees Celsius. 10 times 100%. Now, this is for a period of 1 hour. This is your consideration. So after 1 hour, okay, in your experiment, so in your research study, you conduct an experiment. No? You conducted an experiment. So, and in that experiment, you will measure the energy measurement at 40 degrees Celsius versus the energy measurement at 28 degrees Celsius. So you will compare and then you will get the energy error, no, expressed in percent. And take note, this percent energy error is a random variable. Okay. because for every meter, from my example, I have selected 6 meters, of which 3 meters for type A and 3 meters for type B. So from these 6 meters, okay, I will measure the percent energy error, now considering for every meter. Meter A, meter 1, what is the percent energy error? Meter 2, meter 3, until meter 6. No? So that is your random variable. No? So, so for example, let me represent percent energy error equal to x. So this is my random variable x. And I have measured the energy error in percent of those 6 meters. Okay? I want to get the average. So getting the average denoted by x bar. So first meter 1, okay, meter 2, meter n, okay, over n. So I have 6 meters to, that I considered. So I have x sub 1, x sub 2, up to x sub 6 over 6. Okay, now take note, no? X sub 1 is the random variable for meter 1, no? So this is random variable for meter 1. No? There, no? Random variable for meter 1. Okay? Now, this random variable, well, depending on the selected meter, no? So this can vary, no? Depending on the meter that we have selected. So x sub 1 is the random variable for meter 1. Then x sub 2, random variable for meter 2. And until we reach x sub 6, random variable for meter 6. Okay, there. Alright, so let me further discuss. Now, this x bar, which is the average of the 6 random variables, okay, is what we call as a statistic. So this is now your statistic. So take note, any function of the random variables. So it is a function of the random variables, meaning it is a dependent variable. Now, the value depends on the values of the random variables. Okay? So it is any function of the random variables constituting a random sample. So therefore, these six, no, these 6 random variables is what we call as our sample, and they are taken at random. That's why we have random sample. Okay, so x sub 1, x sub 2, x sub 3, okay, x sub 4 and x sub 5, x sub 6, no? X sub 1, x sub 2, up to x sub 6 is your random sample. Okay, so constituting a random sample, that's it. No? So now, for example, if for example for meter 1, you got 6 random variables. Okay, 6 random variables. Okay, 6 random variables. Okay, 6 random variables. Okay, for meter 1, you got 6 random variables. For meter 1, you got 6 random variables. Okay, 6 random variables. Okay, for meter 2, you got 6 random variables. Okay, 6 random variables. Okay, for meter 3, you got 6 random variables. Okay, 6 random variables. Okay, for meter 4, you got 6 random variables. Okay, 6 random variables. Okay, for meter 5, you got 6 random variables. Okay, 6 random variables. Okay, for meter 6, you got 6 random variables. Okay, 6 random variables. Okay, for meter 7, you got 6 random variables. Okay, 6 random variables. Okay, for meter 8, you got 6 random variables. Okay, 6 random variables. Okay, for meter 9, you got 6 random variables. Okay, 6 random variables. Okay, for meter 10, you got 6 percent energy error or sensitivity of 2%. For meter 2, 3%. For meter 3, 3% again. For meter 4, 5%. No, using this formula. No? For meter 5, 3%. For meter 6, 2%. There. Then divide by 6. So you will get 3% average. 18% over 6. 3%. So 3% as the value of the statistic. This is now the value of the statistic. No? And 2%, 3%, 3%, up to 2% are the values of the random variables. No? So we now proceed. So here's the example. Another example. So if one makes a random selection of n equals to 8 storage batteries from a manufacturing process that has maintained the same specification throughout and records the length of life for each battery. Okay? With the first measurement x sub 1 being a value of x sub 1. So the value is x sub 1, the value of the random variable. Okay? The second measurement x sub 2 being a value of the x sub 2 random variable. And so forth. Then x sub 1 up to x sub 8 are the values of the random sample. X sub 1 to x sub 8. Okay? Suppose the average of 8 random variables are obtained by the formula. So this average is what we call now as a statistic. Okay? Because it is a function of the random variables constituting a random sample. So we now proceed. Now, from a random sample of size n, the random variables x sub 1 up to x sub n have values x sub 1, x sub 2 up to x sub n, respectively. Okay? So that's it. Now, let's talk about sampling distribution. What is a sampling distribution? It is the probability distribution of a statistic. Okay, I have already taught you about probability distribution before, right? In chapter 3, which is the probability distribution of a random variable. This time, probability distribution of a statistic. And the probability distribution of a statistic is what we call as sampling distribution. Okay? So, in short, when we talk about a statistic, it is a characteristic of the sample, of the random sample, or simply sample. Okay? Characteristic of the sample. So this characteristic of the sample is statistic, called statistic. Unlike in the characteristic of the population is called parameter. Okay? So we now proceed. So we're now ready to study about location measures of a sample. So we have the sample mean, the sample median, and the sample mode. So if I'm not mistaken, you have already knowledge about these topics, no? You have studied in first year mathematics in the modern world subject, no? So maybe you have studied these topics, no? So let's proceed with the first one, the sample mean. So the sample mean is denoted by x bar. So this is the formula: summation x of I from I equals to 1 to n all over n. So this is simply x of 1 plus x of 2 up to x of n all over n. And for the sample median, x of n plus 1 over 2 if n is odd. X of n plus over 2 plus x of n over 2 plus 1 over 2 if n is even, such that n is greater than or equal to 1. Okay? And x of 1 is less than x of 2, x of 2 is less than x of 3, and so forth. No? Or x of 1 is greater than x of 2, x of 2 is greater than x of 3, and so forth. So I'll introduce an example later so that you can able to appreciate, no, this formula. So the sample mode. So when we talk about mode, the data value with the highest frequency of appearance in a set of data. Okay. So for the mode, no. So when we talk about data value, this is the observation. Okay. Observation with the highest frequency of appearance in a set of data. So later we'll have an example. So problem solving on location measures of a sample. Suppose the data set consists of the following observations. Okay, considering these observations, what is the sample mean, the median, and the mode? The sample mean, the sample median, and sample mode. Solution. Arranging the observations in ascending order from lowest to highest. Okay, that is ascending order, lowest to highest. So this is now the arrangement. Lowest number is 0.28. No? Then second lowest is 0.32 and so forth. So arranging, we have this one, and we now have x of 1, x of 1 value, x of 2 value, x of 3 values, okay, and so forth. So for the sample mean, so this is the formula. Okay, so we have 10 observations, right? So we have 10 observations on up to x of 10. So we substitute all of those, we'll get an answer of 0.399. Now for the sample median, so here's the formula. No? X of n plus 1 over 2 if n is odd, x of n over 2 plus x of n over 2 plus 1 over all over 2 if n is even. Okay? And so forth. So let's consider the sample median, finding the sample median. So this we arrange first the observations in ascending order, and then these are now the corresponding values of the random variable: x of 1, x of 2, x of 3, and so forth. Okay, counting the number of observations, n is 10, right? So if n is 10, what is that? Is it odd or even? 10 is even. So when we talk about median, the center of the data set, no, will find the observation, no, which is at the center. Okay, since n is 10, it is even. we have two centers, right? That's why, since we have two centers, center observations, no? So we have two center observations. So that's why we get the average. We add, then we divide by 2, no? To obtain the median. So in here, we use this formula because n is even. And if we consider this, that is x sub 5. 10 over 2 is 5. 10 over 2 plus 1 is 6. So we will add x sub 5 and x sub 6. No? They are at the center because they are at the center. No? So these are the values. No? Lower than x sub 5. These are the values higher than x sub 6. Okay? And this is the center. Okay? So you get the average x sub 5 plus x sub 6 all over 2. And that is simply the median. Okay? So this is the notation of the median. X with a, if I'm not mistaken, this is tilde. No? Tilde. This symbol. So we now proceed. No? So we now proceed. So we have, so we now proceed. So we have 0.38 plus 0.42 all over 2. So that is 0.4. So that is now the median. Now for the mode, data value with the highest frequency of appearance in a set of data. So given the arranged observations in ascending order, so which is the data value or observation with the highest frequency of appearance? So the mode is x sub 7, right? 0 and equal to x sub 8, right? So that's the mode. Highest frequency is 0.43, isn't it? Okay. So take note that if all values are different, your answer will be no mode. If you have, uh, if you have, for example, this is 0.37. Okay, so you will have two modes. 0.37, 0.37 occurs twice. This occurs twice also. So you have two modes, 0.37 and 0.43, and that is bimodal. So you can also have three modes, trimodal, and so forth. Okay? But if all are different, that is no mode. So let's now proceed with variability measures of a sample. So we have the sample variance. So then the sample standard deviation, the sample range. Okay? So we have the sample variance. So I think you have also encountered this before. Okay, so we proceed. So S squared is equal to summation x sub I minus x bar squared all over n minus 1. So this is the notation for variance. We use S squared. Okay, and then x sub I is your observation. Okay, value of the observation. Okay, or data value. So the ith data value. Then we have x bar as the mean. So this is the mean, okay? So this is the mean, and all over n minus 1, okay? So then this is the formula, x sub 1 minus x bar squared plus x sub 2 minus x bar squared, and so forth. So with the absence of the sample mean, this will be the formula, okay? So let me continue now. So we have the sample standard deviation now. So that is simply the square root of s squared. So the square root of the variance is called the standard deviation. Okay. Then the sample range, which is the maximum data value minus the minimum data value. No, the maximum value of the observation. No, among the observations, the maximum value. Okay, minus the minimum value among the observations. So highest value of the observation in a sample. Okay, highest value of the observation in a sample. So that is x max. Lowest value of the observation in a sample. That is x min. Okay. Problem solving on variability measures of a sample. So we have this example. So we have a comparison of coffee prices at four randomly selected grocery stores in Santiago showed increases from the previous month of 12, 15, 17, and 20 cents for a pound of bag. Okay, for a 1 pound of bag. Find the variance, standard deviation, and range of this random sample of price increases. So here are the price increases. Okay, so we're required to find for variance, standard deviation, and the range. Okay, solution. So given price increases, we know those. We have s squared, s, and r. Okay, and then for the solution of the problem, no. So for the variance of the sample, so we use this formula. No. Now applying this formula for n equals to 4. No. N is 4. Okay. And we'll arrive with an answer of 11.33 square cents. So that is our answer. No? 11.33 square cents. So we have a total number of 4 observations, right? N is 4. The price increases are as follows: 12 cents, 15 cents, 17 cents, and 20 cents. We have a total number of 4 observations. And then, so that's it, no? So we now proceed, no? So for the standard deviation of the random sample, so we just take the square root, no? And we get 3.37 cents. For the range of the random sample, okay, the highest value, no? Highest data value minus the lowest data value, no? So so we have, so given the price increases, so the highest value The highest observation value, no, is 20 cents. The lowest observation value, okay, is 12 cents. Okay, that's why we have 8 cents as our answer. So that's now the range. The range of the random sample is 8 cents. No? All right. Then we have here sampling distribution of the mean and the central limit theorem. Okay, so before I'll discuss this, let me introduce to you on how to use your calculator. No? Okay, so let's proceed here. The finding the mean. So we have, so I'll teach you how to use this calculator. Shift mode, shift setup, mode, no, the other one, mode, mode 3, mode 3 for statistics. Then we have here, let's press AC, okay. Then shift 1, then enter the data. So the data are as follows: 0.32, 0.53, 0.28, 0.37, 0.47, 0.43, 0.36, 0.42, 0.38, 0.43. Okay, so we have those. Then press AC, then shift 1. Then we have here finding the sample mean. Okay, sample mean. So our sample mean is, so where can we find the sample mean? Type 4. There we have, we can determine the sample mean. We have 2. Okay, we have 2 x bar. There 0.399. So we have 0.399. Okay, so that's it. Now for the median and mode, we don't have a way on how to get it in the calculator now. So let me show you how to use the calculator for finding the standard deviation. No? Okay, for the standard deviation, so we have 12 cents. No? So shift 1, data. So we have 12 cents followed by 15 cents, followed by 17 cents, 20. Okay, delete. Oh, delete those there. So you have four observations. Okay, and then we have, let's find the standard deviation. Shift 1, then 4. We have here Sx. This is for the sample standard deviation. 3.36. So let's see. That is 3.37 cents. Okay. 3.37 cents. Okay. So that's it. So I hope you get it now. Alright. That's all. Good day, everyone.